Alright, in the previous lecture we have learned how Dijkstra's algorithm work for single source short path problems. And we have created Dijkstra's algorithm in practice using Java programming language. Now in this lecture, let's see why Dijkstra's algorithm does not work when we have a negative cycle in our graph. Now before continuing, let's identify what the negative cycle means in a graph. So let's say we have a graph like this. So in this case, first we need to identify if we have a cycle in our graph or not. So in this case, we can easily see that we have a cycle in our graph over here. So because in this case, if I go from A, I can come to A by using other nodes over here. So if I go from A to D, then from D to B, then from B to A, you see that we have a cycle over here. So after identifying the cycle, let's identify what's a negative cycle. So a path is called negative cycle if there's a cycle. So we have found that we have a cycle. So a cycle is a path of edges or vertices wherein a vertex is reachable from itself. So this means that from A, if I leave to D and B, we can come back to A. So the first property is there should be a cycle, and the second property is the total weight of cycle is a negative number. So this means that if I sum up these numbers from A to D and from D to B and from B to A, we are going to get negative number. So here we can easily see that the sum of these numbers is -1. So this means that in this case, we have a negative cycle in our graph. So hopefully you have understood what's the negative cycle. So let's look at why it's not working with Dijkstra's algorithm. So here the issue is we cannot never find the minimum distance in a negative cycle. So if we try to find minimum path from A to B, in this case we can see that we have to come to D, then from D we can come to B. So in this case, if I calculate the cost of this path, we are getting -5. So here we might think that this is the minimum cost in our case, but if we do one more cycle over here, we are going to get a number which is less than -5 over here. Now if you go from B to A, then come to D, then come to again B, in this case you are going to see that the cost is -7. So from B to A is 3, and from A to D is -6, and from D to B is 1. So if we sum up them, we are going to get -7. So this means that -7 is less than -5. So in this case, this second option is with less cost. So if we do one more cycle over here, we are going to get -9. So if we do one more cycle over here, we are going to get -11. So as you can see, the more cycle we take, every time the distance starts decreasing. So basically there is no answer in that case. So in each cycle, the path becomes less. So this will continue until infinity. So this means that we will never find an answer. So this is the reason why Dijkstra's algorithm cannot find a solution when there is a negative cycle. So how can we deal with this? So you might be thinking that we can just return a message to a user saying that there is a negative cycle in a graph. But in this case, the problem is Dijkstra's algorithm cannot catch negative cycle. So this means that we cannot stop over here. So you might be interested that how can we deal with this problem? So for such cases, we have another algorithm, which is Bellman-Ford algorithm. And Bellman-Ford algorithm deals with negative cycles successfully. Now in the next section, we are going to learn everything about Bellman-Ford algorithm. So see you in the next section.